All right, here we go. We're going to get through these notes pretty quickly. Don't worry, we're not going to rush through it. It's just the whole 30 minutes is probably going to be consumed with this. So when you guys come back, we're going to have quizzes, and your quizzes are going to look just like this front page. I think I gave you a sample page of how it looks. I'm not going to grade the back part of the quiz. The back part of the quiz has a unit circle that is just for your reference. They're going to be timed. In the beginning, it's going to be 10 minutes. I think the one I gave you had a timer of 7 minutes. The least amount of time that I'm going to give you is 6 minutes, but that's not until we're pretty good. The first 5, I'm going to drop, unless you have a good grade and you agree that you like it, and I put the grade in. I put in here that if it's above a 75, I'm going to count it. In reality, if it's a 75 or an 80, I will ask you, do you want this grade? And if you say no, I'll just drop it. And then whatever the highest grade is after the 5th one, that's the one I'm going to put in. Cool? So the first 5 I'm going to drop, and then I think I'm going to take the top 3 highest grades out of the next 5. So if you get 3 100s in a row, you are done and you no longer have to take the quiz. But you got to get them in a row. So if you get 2 100s in a row and you don't get 100 on the 3rd one, then it starts again. And we're going to be taking this is going to be our warm-up for the next 3-4 weeks. Like every day you come in and you're just going to take that. Now if you get here a little ahead, you guys have the advantage because you guys are first period. So if you guys get here like 5 minutes early, then it's not going to count against your timer. You can just say, Chavez, can I start the quiz? And doot. So that's your incentive if you want to get here early. Don't skip breakfast. Go get your breakfast. You can eat your breakfast while doing it. So there it is. You don't have to come in early. You can just come in time, and you'll get your whatever the time is worth for the quiz. Does that make sense, guys? Yes. Cool. All right. So what am I going to want from your quiz? So here's what I'm going to want. So it says 10 to the power over 3. You got no calculators. You got to tell me what 10 to the power over 3 is. Some of you know that power over 3 in the unit circle is the same as 60 degrees. It's up here. And that coordinate is 1/2 comma square root of 3 over 2. Now, if you remember, tan is y over x. So, what I want, if you tell me square root of 3 over 2 divided by half, I will put okay. It's not wrong. It's an okay answer. What's a better answer? Square root of 3. Square root of 3 is actually the best answer. Yes. Sorry. And there it is. That's it. Sorry. You know what? Let me make it better because it's going to bother me that it says equals in the bottom there. Equals square root of 3. There we go. All right. Secant of 5 power over 6. Where is 5 power over 6 in the unit circle? It's in quadrant 2. Remember that in 5 power over 6 is the coordinate negative square root of 3 over 2 comma half. Secant is the reciprocal of which one? Cosine. So you're going to write negative 2 over square root of 3. This is an okay answer. It's not wrong. It's fine because I didn't tell you how to do it. You leave that answer. I'll count it correct. The preferred answer is negative 2 square root of 3 over 3 because that one's rationalized. But either one of those, because it's a time test, I understand you're in a hurry. So if you just want to give the first one, that's fine. Cool? All right, let's go through it. Cosine 3 pi over 2. What's the x coordinate at 3 pi over 2? You guys okay? 0, yeah. Cosecant 5 pi over 6. Cosecant's the reciprocal of sine. So sine was a half, so the reciprocal is 2. Cosecant of 11 pi over 6. Cosecant's the reciprocal of sine again. Sine in quadrant 4 is negative, so this one is a negative 2. Because it would have been negative half. Cotangent. Cotangent of pi over 3 is x divided by y. So let's see, half divided by square root of 3 over 2. I'll put okay for that one. 1 over square root of 3. That's better. And the best answer is square root of 3 over 3. This is best. All 3 are correct. All 3 are correct. Whichever one you think of first. Sine of 2 pi. Oh man. 0. You've done a whole revolution. You're at coordinate 1, 0. Sine is the y value. Tan of 11 pi over 6. You're in quadrant 4, so it's going to be negative. Because negative divided by positive. Y is a half, or a negative half, but I put the negative in the front. X is square root of 3 over 2. So that's an okay answer. 1 over square root of 3 negative is better, and negative square root of 3 over 3 is the best. Cool. Cosecant of 3 pi over 4, that's the reciprocal of sine. At 3 pi over 4, you're in quadrant 2. So 2 over square root of 2, or if you're what happened? If you're rationalizing it, that's going to be 2 square root of 2 over 2, so square root of 2. How do you guys feel? All right. Cosecant of 30 degrees. Cosecant is the reciprocal of sine. Sine of 30 degrees is a half, so 2. Secant of 120. Secant of 120 is the secant is the reciprocal of cosine. Cosine is a negative half, so there's going to be a negative 2. Cotangent of 150, x divided by y. So let's see, square root of 3 over 2, negative, right? Divided by a half, so negative square root of 3. Sine of 300, sine is a y value, so negative square root of 3 over 2. Sine of 270, negative 1. And then finally, tan of 315, you cut quadrant 4 right in the middle, so negative 1. Or you can also say negative square root of 2 over 2 over square root of 2 over 2. Negative 1. Yay or nay? Okay. All right. Before we continue into the second page, let me help you guys out a little bit. Yes, you can just memorize by brute force unit circle, but guys, be smarter. Like, I don't know if there's a way you can like categorize your memory. So what I mean by that, here, I'm going to do it in blue. Cosine pi over 6, cosine 5 pi over 6, cosine 7 pi over 6, cosine 11 pi over 6. Okay, work smarter, not harder. You guys ready? All of these, if you pay attention to the unit circle, all of these are all related. All of them have the magnitude of square root of 3 over 2. All of them. Now I got to figure out which one's positive, which one's negative. I know that pi over 6 is in quadrant 1, and I know that the x in quadrant 1 is positive, so pi over 6 is a positive one, the coordinate. I know that 5 pi over 6 is in quadrant 2, and I know that the x coordinate, which is what the cosine is related to, is negative in quadrant 2, so negative. 7 pi over 6, that's quadrant 3. Everything's negative in quadrant 3. And 11 pi over 6, we're in quadrant 4. The x coordinate is positive, so there it is. Notice, done. If you are smart with your brain, don't make yourself work so hard, guys. Just categorize it in your brain. Like, oh, all the something over 6's for cosine are always square root over 2. Now you just got to know your little concepts. Cosine's the x coordinate. If you're in quadrant 1 or quadrant 4, the x coordinate is positive. If you're in quadrant 2 or quadrant 3, the x coordinate is negative. Do you guys see how we're doing it? So if you're not a robot, if you just memorize a few little, or not even memorize, if you just learn a few little concepts, you can get them all. Oh, how did you get these values? They come from the unit circle. 30, 60, they come from the right triangles. 30, 60, 90, 45, 45, 90 triangle. The unit circle has a radius of 1, so that's like a hypotenuse. So then we just use our properties to get our half and square root of 3 over 2. And the same thing for the 45, 45, 90. Square root of 2 over 2, square root of 2 over 2. They all come from Pythagorean theorem. 30, 60, 90, 45, 45, 90, right triangles. Cool? See, so if you just put all your concepts together, there's nothing to really memorize because you got it all. If you want to memorize stuff, you just memorize quadrant 1. But that's all you got to do. Just memorize quadrant 1 and you got them all. Cool? All right. So here we go. Example 2. This should be a review. I did this on purpose because this is something that I think you guys are comfortable with. You guys did really well in this little section. So it says, find an angle in each quadrant with a common reference angle with 345 degrees from 0 to 360. Well, 345, before I even start, what quadrant is that in? So go to quadrant 4 and put 345 degrees. I'm going to draw a little picture down here because I got some room. So here's my picture. It's not perfect. Here's 345 degrees. Theta equals 345. And I find my reference angle. So I'm going to put it in green. What is this distance in green here? How many degrees am I away from 360? Yeah. 15 degrees. So that I'm going to put in quadrant 1. So what they want is for me to get a 15-degree reference angle in all the quadrants. Here it is, 15. There it is, 15. Here it is, 15. And they want to know what is this angle, the blue one, for quadrant 2. And what is this angle, the black one, in quadrant 3. So the blue one in quadrant 2 is, well, I'm 15 degrees away from 180. So what's 180 minus 15? Yeah, so put 165 degrees in quadrant 2. And I'm trying to color code the notes so it can be better for you guys. So in quadrant 3, notice that I am 15 degrees above 180. So I take the 180 and I add 15 degrees. So what's 180 plus 15? Yeah. And there it is. I got them all. I got all 4 of them. Do you see how we did them, guys? Yeah, I'm trying to go slow, but I don't know if you can tell my voice that I'm going fast and I'm fighting to go slow. So I'm fighting. I'm trying really hard to okay, slow down. So I'm trying, guys. I'm trying my best. All right. Ready for the next one? Yeah. Okay. So here we go. I'm going to draw a little grid. And I'm going to try to color code it as well. First, draw 121. So here's 121. What quadrant is that in? 2. So they already give me one. They already give me the quadrant 2 one. I'm going to put the word here, given. So as soon as you see that, you write that. They say they want the reference angle. So I'm going to find this guy right here in red. I'm going to call that reference. What is that reference angle? Yeah, how'd you do that so fast? Perfect. So to get the reference angle, you just go 180 minus 121. So 59 degrees. As soon as you get the reference angle, that's quadrant 1. And then I'm going to draw my reference angle in all of them. So here's my reference angle. Okay, now let me color code it. You already got this one, so that's the one's already in red. Quadrant 1, reference angle. Now I want the one in green here. That one in green, I know that I'm going to take the 180 and I'm going to add that reference angle. So 180 plus 59. All right, now how do I get the one? Let me change it to, what color have I not used? Blue. I want this one in blue. Perfect. 360 minus 59. What is that? There you go. And that's how you get all 4 of those angles. And you guys did this already earlier, so you guys will probably be beast on this little section here. All right. Now, take out your unit circle. I think it's easiest if you look at your unit circle. So do you have a unit circle with you somewhere? Yeah, take it out, guys. Yeah, try to figure out a system. Does anyone have a digital system in place? I've been thinking about it. I think like for notes and stuff. I mean, I have almost everything ready to go, I think, too. Because I have all the PDF documents. I can create a folder digitally and swipe. But I don't know. So I think right now would be the perfect time to transition. Like if you guys have an iPad Pro or some type of tablet, to transition to all digital notes. I don't know if it's better or not. I still like physical notes better at the moment. Because what if your battery dies? Like, oh, I need to look at my notes. Okay, I'll stop. All right, here we go. Look at your unit circle. Go to 330 degrees. What is sine of 330 degrees? Perfect. So the question is saying, expresses a function of a different angle. So here's what I'm going to ask. Sine of what other angle, question mark, will also give me negative 1/2. So look at your unit circle. And you're going to look specifically in quadrant 3, because sine is a y value, and if you want it to be a negative value, you got to look either in 3 or 4. So we already used 4. So what's the one in quadrant 3? What is it? Yeah, 210. So there it is. That's it. That's all they wanted. Now, so what's the game plan for this? Like, how would you figure this out on your own? So, okay, we'll get there for the next questions because I don't want to waste time on this one. Do you see how we did this one? So when you get to delta math, you can just do all these just by looking at your unit circle. They're all going to be very basic. They're going to be like that. I'll show you the more advanced ones in a little bit. So look at this one, example 5, cosine 30. So look at your unit circle. What is cosine 30 degrees? And it wants the same thing. It says express it as a function with a different angle. So because it's cosine and it's positive, I am looking specifically in quadrant 1 and quadrant 4. You're not going to look in quadrant 2 or 3 because cosine's negative there. So in quadrant 4, where do I have another positive square root of 3 over 2? 330. And don't worry, in a little bit I'll show you the right way to do this. So there it is, 330. Oh, square root of 3 over 2. There we go. 330 degrees is the answer. Do you see how we did it? Okay. So look at example 6. Now we're talking. 255 is not a special angle on the unit circle. But we can figure it out. We can figure this out. So tan, look, what quadrant is 255 in? So I'm going to draw a sketch, and I'm going to say, I don't know, I'm somewhere like right there somewhere. I'm going to say that is 255. And we know, what do we know from past experience? That tan of some angle is y divided by x. Correct? All right. In quadrant 3, what's the, I just want to know the signs. Are my coordinates x and y both positive, both negative? Is one positive, is one negative? Both are negative. So if I were to write tan of 255 degrees, I know that I have some negative y value, and I'm going to put the y value in quotes, and I have some negative x value. What's negative divided by a positive? Uh-oh. I'm sorry. I said it wrong. What's negative divided by a negative? Positive. Yeah. So negative divided by a negative is a positive. So besides 255, here's the game plan for this. I'm going to find that reference angle. How do I find that reference angle? Yeah, 255 minus 180. What do you get there? Yes, 50, 60, 70. Yeah, 75. Or is it 65? Yeah, 75. So that must mean that distance right there must give me the same as tan 255. Chavez, why? Because tan of 75 is y divided by x, and both of those coordinates are positive. It's the same magnitude as the magnitude of 255. It actually is negative divided by negative is a positive. So in quadrant 1, what I'm trying to say is this. Let's do one that we know. Tan of 30 degrees is y divided by x, so 1/2 divided by square root of 3 over 2. So 1 over square root of 3. And tan of 210 degrees is negative half divided by negative square root of 3 over 2. I'm just using this as an example. You don't have to write this down. Negative 1 divided by negative square root of 3, negative divided by negative, and we get that. Do you see how these are the same? So notice, what do they have in common? The reference angles. 210 degrees, the reference angle is 30 degrees. Do you guys see that? 210 minus 180, that's 30. So as soon as you get your reference angle from quadrant 3, you know that reference angle will get you that same value for if you use tan. Cool? And it is. That's the answer. Check it out. Let me get my calculator out really quick. So calculator out. One of these days, these will be voice activated, and you can just go TI-84 out. But we're probably like 5 years away from that.
Well, they already have like the Hey Siri, and then obviously like all the Siris.
Hey Siri. Oh wow. Okay. All right. All right. I'm in degree mode. Tan of what was it? 255.
Yes.
So let's see. Tan of 255. Enter. 3.73. So then we said tan of what? And look at that. Digit per digit. It's the same. Isn't that cool? Yeah, because we just use math. We just use the logic, guys. All right. Let's go now to these. I really like these questions here because you don't have to do anything like hard calculations. You just got to think a little bit. Just a little bit. a little bit. So check it out. It says determine the possible quadrants in which theta could lie. Cotangent. Cotangent is what divided by what? Well, the other way around. X over y. So x over y, what two quadrants will x divided by y give me a negative value? Yeah, be confident. It's all good. Safe space, guys. 2 and 4. In quadrant 2, the x is negative, y is positive. So negative divided by positive is negative. In quadrant 4, x is positive, y is negative. And it's okay, guys. If you say a wrong answer, it is a safe space. No one's going to judge. Are we cool?
Yeah.
Letter B, cotangent, square root of 2. In what two quadrants will cotangent be positive? 1. Perfect. 1 and 3. Because in 3, negative divided by negative is a positive. Do you see how we did it? If you want to go faster than me, go for it, guys. Secant is the reciprocal of cosine. Where is cosine negative? Don't look up. 2 and 3. I'm so dumb. Did you see what I just did, guys? I said don't look up, and then I covered my tablet thinking that you wouldn't be able to see. But
No one even looked.
I know. Man, so dumb sometimes. I'm not calling myself dumb. That was just, okay, anyways. Cosine, 3/10. In what two quadrants is cosine positive? Where and where? 1 and 4. I did think about writing a wrong one on purpose to see if you guys would follow. But tangent, where am I positive? 1 and 3. And then finally, sine. Where is sine positive? 1 and 2. Write Roman numerals when you're writing quadrants. I have never, ever seen it in a textbook written as a numeric number. I've always seen it written as a numeral, as a Roman numeral. Not really sure the exact reason for that, but I'm sure there's something to it. Maybe YouTube can help me out and fill me in on that. All right, here we go. Given the following point on the unit circle, find the angle to the nearest tenth of a degree of the terminal side through that point between 0 and 360. All right, I'm going to draw. You don't have to be perfect. So here's my grid. I have a unit circle here. So that means the radius is what? 1. And it doesn't have to be a perfect, guys. You just got to get the right quadrant correctly. The negative 2 square root of 3 and the negative square root of 7 over 3. What quadrant is that in? 3. So I'm going to say that there it is. And I don't know if I put it kind of close to the middle. It probably isn't, but that's fine. Negative square root of 2 over 3. Negative square root of 7 over 3. Let me tell you the best plan. In the past, I guess let me tell a real quick story, 30 seconds. In the past, I used to not do it this way. I would just tell you, do arc sine with that negative and arc cosine with that negative, and then remember where you are at, and then calibrate, blah, blah, blah. And there was always errors, like not everyone, but errors here and there. And then I decided one year to just scrap that and then just do it this way, which I'm about to tell you guys. And after that, it was like 100% getting it correct all the time. So I was like, okay, that's a better route then. All right, so here's how you're going to do it. You're going to do it with reference angles. And you'll always get it right because you know that you just calculated a reference angle. So I'm going to draw a triangle. I already drew that red line there. So here's my triangle. Do you see that? And I'm going to calculate this one right there, theta r. And then once I calculate theta r, I'm going to find the real angle, which is this one in blue that I want. And I'm going to color code it for you guys. Are we okay so far?
Yeah.
All right. You will always find a reference angle if you always use the positive coordinate. And before I even get to, oh man, do you guys know what an inverse cosine is or an arc cosine is? Okay, let's talk about that. Man, there's so many things I got to talk about. Side note, put a side note somewhere, SN. 5x equals 15. If I told you that you cannot divide, you can't divide, but I want you to solve for x, then you would probably tell me multiply by the reciprocal, and that will get you the answer. And you're right. You're right. That would get me the answer. If I go 5 to the power negative 1, there it is, times 15, that will get me that 3. Are we cool? Okay. So if I tell you, and this is still part of my side note, if I want cosine of some angle equals square root of 3 over 2, because we know what that angle is, that's 30 degrees. if I want you to find theta, but let's say we didn't know, you would do what's called the inverse. So theta is equal to cosine inverse, or you say inverse cosine first. Inverse cosine of square root of 3 over 2. You can also say the word arc. So there are two words that mean the same thing. So repeat after me. Inverse cosine, and then arc cosine. Okay, one more time. Inverse cosine, arc cosine. Perfect. Never say, especially to a professor who's been studying math for 20, 30 years with a PhD, never say cosine to the negative 1. Never say that. Never. Say inverse cosine or arc cosine. If you say cosine to the negative 1, he's going to understand that you're trying to say reciprocal. Or he might, if you're doing this, he might understand that you're trying to say this. But if you say it verbally, cosine negative 1, you're saying reciprocal cosine, which is not the same. Cool? Okay, so here we go. The reciprocal cosine, by the way, is secant. All right, anyways, so here we go. So what is this called? Inverse cosine or arc cosine. All right, don't worry, I see them, but don't worry. We're still good. So check it out. If I type second arc cosine there of square root of 3 over 2. Oh, man, come on, buddy. Look at that. I get 30. Cool? Yeah. So don't worry, guys. We're still good. We're still good. So look. Finally, theta r equals arc cosine of square root of 2 over 3. That's going to give me a positive angle. And they should give me, just for kicks, this will be the last one. We're pretty much already done anyways, the last two anyways. Square root of 7 over 3. And those better give me the same answer. So check it out. And this will be the last one, guys. Second arc cosine. What did I have again? Square root of what? 2 over 3? Over 3 for arc cosine, right? So I get 61.8 or 61.9. Let's do the other one. Arc sine. And what was the number? Square root of 7 over 3. And check it out. It's going to be the same. Now, those are both my reference angles. So 61.9 degrees. If those are my reference angles, so then how do I get my blue angle? You add, perfect. So the blue angle is 180 plus the red one, 61.9. And that is 180 plus, come on, buddy. And there it is, 241.9 degrees. Did we see how we got it, guys? Do you think you guys can repeat? All right, we're good. I'll finish this off, guys, and then I'll post a video if you want to see the last example. What's up?
Can you write an upfront for Miss Kilgore?
Oh, you know what? If Miss Kilgore has a problem, tell her to call me.
Okay.
Go for it. So here we go, example 9. Help me out. So the first thing I would like to do on example 9 is they tell me I have a unit circle and I have this coordinate. So here's a grid, x, y, and that coordinate is in what quadrant? 4. So here's my unit circle, and I'm going to say it's this point. I don't know where exactly it's at, but we're going to say it's that point. So what you're going to do, draw a triangle like so. See? And what we're going to find our reference angle, that guy. So how do we find our reference angle? Do you guys remember?
Yeah.
So we're going to say cosine of that reference angle equals what? Perfect, arc cosine. So let me do the other one as well. Sine of that reference angle, and I don't put that negative, I just write perfect. So this one, theta r equals what I call either arc cosine or perfect. Both mean the same. Never say cosine of the negative 1, because that does not, yeah, they're just going to laugh at you. Tell them you're from Jeff High School or something. If you, all right, so here we go. Arc cosine of square root of 11 over 4, and that's going to give me a number, which is going to be my reference angle. And same thing with this one, theta r equals, what do I say? Arc sine of
Square root of 5 over 4.
and that better be the same angle. If it's not, there's some issues, right? So here we go. And by the way, the reason we can do that is because the hypotenuse is 1, because the radius is 1. So we know adjacent over hypotenuse, anything divided by 1 is itself, so that's why we can just use that coordinate, right? Okay, so here we go. I'm going to type the calculator, and I already forgot those numbers, short-term memory. Arc, cosine, and what was it, square root of?
Square root of 11 over 4.
Yeah. Enter. 33.98, so we're going to say 34. So let's see, let's do the other one just for kicks. Arc sine of, what was it?
Square root of 5 over 4.
Good job. Oh,
I wasn't even looking. Wait, what is that? Did you say babe?
there we go. Did we get the same answer? Yeah, we did. Now, that's not our solution, though. That's just the reference angle. So how do I get perfect? So the blue one is 360 minus that answer that we got. What was it, 34? So we are going to get what? And there it is, guys. That's how we do it. So go ahead and tackle your delta.